Scientists synchronized the brain, and people became more generous. For generations, generosity has been framed as a matter of upbringing, culture, or personal values. We teach children to share. We praise kindness. We assume that altruism reflects character. But what if generosity is not just a moral choice? What if it is also a neural process? A new study published in PLOS Biology suggests that the willingness to share may depend, at least in part, on how effectively specific brain regions communicate with each other. By gently synchronizing activity between two areas of the brain, researchers were able to make people measurably more generous, even when generosity came at a personal financial cost. If you like my videos, subscribe my channel and press the bell icon to turn notifications on so you keep getting all the major advancements in science and technology. And don't forget to like and share this video with your friends and colleagues. Now, consider this. What if your willingness to help someone isn't only about who you are, but about how your brain is wired in that moment? Could cooperation be strengthened by tuning neural rhythms? And if generosity can be increased, what does that mean for how we understand morality itself? The experiment, testing altruism in real decisions. To explore the neural basis of generosity, researchers recruited 44 participants and asked them to play a well-known behavioral economics task called the Dictator Game. In each of 540 trials, participants decided how to divide a sum of money between themselves and another person. Sometimes sharing meant equal gain. Sometimes generosity required sacrificing personal profit. This setup allowed scientists to measure altruistic decision-making under controlled yet meaningful conditions. While participants made these choices, researchers applied transcranial alternating current stimulation, TCAs, a non-invasive method that delivers weak electrical currents through the scalp. The goal was not to activate a brain region, but to synchronize neural oscillations between two specific areas. The frontal cortex, associated with decision-making and value evaluation. The parietal cortex, linked to perspective-taking and social reasoning. The stimulation aligned neural firing patterns at specific frequencies, particularly in the gamma range, which is often associated with higher-order cognitive processing. What changed in the brain and in behavior? When gamma synchrony between the frontal and parietal regions was enhanced, participants became modestly but consistently more generous. They were more likely to share larger portions of money, accept lower personal payoffs, weigh the other person's outcome more heavily in their decisions. Computational modeling revealed something subtle but powerful. The stimulation shifted how participants evaluated trade-offs. After synchronization, individuals assigned greater importance to the welfare of others when calculating their choices. Importantly, the researchers did not directly record neural activity during stimulation, so future studies combining TACs with EEG will be needed to confirm the exact neural mechanisms. Still, the behavioral effect was clear. Modifying communication within a specific brain network changed how people balance self-interest and altruism. Evidence of causality in social behavior. One of the most significant aspects of the study is its demonstration of cause and effect. Previous research had identified correlations between brain activity patterns and altruistic behavior. This study went further. When researchers altered neural coordination in a targeted way, social decisions shifted predictably. Rather than simply observing generosity, the team experimentally influenced the neural circuitry underlying. The findings suggest that altruistic decision-making depends on coordinated communication between brain systems responsible for value computation and social perspective-taking. What does this mean for society? This research does not imply that morality can be engineered or that generosity is purely mechanical. Human behavior remains shaped by upbringing, culture, context, and conscious reflection. However, the study raises profound questions. If cooperation depends partly on neural synchrony, could disruptions in brain communication contribute to social dysfunction? Could targeted brain stimulation one day support rehabilitation in disorders that affect social behavior? And where do we draw the ethical line between understanding generosity and attempting to enhance it? At its core, this research reframes altruism not as a fixed personality trait, but as an emergent property of dynamic brain networks. The next time you choose to help someone, or decide not to, it may not only reflect your values, but also the invisible rhythms coordinating activity inside your